So now we know what goes into an Android app. Let's start diving deeper. We'll start to talk about Android activities, learn a bit about them, and think about how they'll fit in our app before we jump over to Android Studio and start adding them when we begin to build out our interface. No better way to answer the question of what is an activity than to jump to the Android documentation. An Android activity serves as the entry point for an app's interaction with the user, providing the window in which the app draws the UI. Now you might be thinking, Alex, didn't you just say you were going to create an activity for each one of our pages? But this says it's the app's entry point for the window. This definition does make it sound like an activity represents an entire application, but that isn't really true. We do have access to an application class that wraps the lifecycle of the entire app. However, activities are also not simply pages as we might use them as so often. They can act as an entire application, and there is even a design pattern for building Android applications that uses a single activity and then uses fragments to handle the idea of pages. We'll talk more about how this is possible in the next module on fragments. But for the sake of this application, we will use activities more often and allow for the communication between multiple activities. In the end, we'll have a bit of a blend of fragments and activities to fulfill our application page requirements. We can break down a very basic activity structure in Android as the starting point for the window of our application. This activity is then filled with views that complete the user interface we see on our device. These views enable the user to interact with our application. In a more advanced situation, we can use some more complex controls such as toolbars and tabs. These views still lie within the activity and can be paired with a combination of views, fragments, and views within those fragments. Activities have a very thorough lifecycle. This lifecycle allows us as developers to tie in custom logic, wire up, or back up during the events in the cycle. These events have accompanied functions that we can override in our custom activity classes within our Kotlin codebase. The first event is the creation of the activity, or the onCreate function in Kotlin. After being created, the activity then starts via the onStart function. The activity resumes with the onResume function, at which point it is running. This means that users are actively interacting with the UI of our activity and using our application within this current activity. When the user is done with the activity, whether going back to a previous one or invoking an action that starts a new one, the current activity is then paused. This is done via the onPause function. From here, the state of the activity can actually go in two directions. If the user goes back to the activity, it will go through the onResume function and begin running again. Alternatively, the user can continue after the app has been paused, such as going back to the previous activity or if they've left the activity to go to a different application. At this point, the onStop function is called. This stops the activity. This stop state can again go in two directions. If the user comes back to the activity, such as going back to your application after leaving to another application or the home page of the phone, the onRestart function is called. This onRestart kicks the chain of events back to the onStart function and so on until the app is running again. Now on the other hand, if the user does not go back and the operating system decides to clean up memory, or if the user closes your app from the switcher, the activity will be kicked over to the onDestroy function. This is the last chance to execute any code before the activity is dead for good. This lifecycle diagram might seem a little confusing, so let's see a quick visual example. Let's say the user is using your app and is currently in one of two activities. When the user clicks on a view, the code of your application starts activity 2. When this happens, activity 1 pauses, and activity 2 is then created. Activity 2 starts, which then moves to resume, and at this point it's running. Now when we go back via the back button or some other means, activity 2 is paused, then stopped, while activity 1 resumes from being paused and is the active running activity again. Now when the Android operating system needs to clean up memory, our second activity is destroyed, at which point it is dead. Here's a simple example of what an activity looks like in Kotlin with each of the overrides of the lifecycle functions. For the first time in this course, we can look at some actual Kotlin code, even something as simple as this. Already we see some great advantages that Kotlin gives us. We don't need to define a constructor or the base constructor of the base class we inherit from. We can pass in nullable parameters into functions and safely handle null checks, or not require them. We have more readable function overrides, and we don't even have to define a return type if it is void, as each of these functions are.